Okay, we're recording our lesson on probability and Venn diagrams, and we'll also look at two-way tables. And again, we're looking at Venn diagram. A, suppose represents those who play water polo. B might represent those who take a stats course. So if you shade the middle, that represents the intersection of both those sets. So that'd be A and B, so people who play water polo and take stats. And I use an example, like let's say John plays water polo and he takes stats, so John would be in the middle here. If you're taking this class and you don't play water polo, you'd be over here. Or let's say there's all these guys on the water polo team are not taking stats, they would be obviously over here. And what if you don't do either? You don't play water polo or you don't take stats, you'd be outside those two circles, but you'd be in the box. Assuming the box represents Sacred Heart students. Because there are Sacred Heart students who don't play water polo and don't take stats, right? There are some that probably do both, some that probably do one or the other. Now, what if I were to shade both circles? Then this means you belong to either A or B. So this scenario would be A or B. So if I want to find all the people who do water polo or stats, then I want all the people in both circles. Of course, you might have to get some people to do both. But if I were to say I want A or B or not both, then I would do this. This would be A or B, but not both. If you want that scenario, just so you know. But let's go back to what we just had originally. Now, what if I had all this shaded? Now, this is going to be neither A nor B. Or you could say not A and not B. Or not and then A and B. You can write that way as well. And then lastly, what if we had like this kind of scenario? So this would be just A. But no B. So you don't want any overlap. So it's just the water polo players right here. So hopefully that makes a little sense. Now let's take a look at some information we have here. So this right here is what we call a two-way table. It's a table that you could read kind of two ways. You can look at homeowners versus not homeowners and high school grads versus not high school grads. And of course, you know, there's an overlap. Like, for example, there's homeowners who are not high school grads. There's high school grads who don't own a house. And we're looking at a total of 500 people. Okay, so let's say set A is being a high school grad. So if you're a high school grad, that's set A. If you're a homeowner, it's set B. So then this would be not B. This would be not A. Usually do like a negative symbol, or some people will do like a little squiggly line, which means not A. That's kind of like using set notation. So let's create a Venn diagram here. Let's say set A is over here. Again, that's a high school grad. Set B, that's a homeowner. Now, anyone want to take a stab to tell me what goes in the middle here? What number would I put in the middle there?
Would it be not A plus not B?
not A would be actually on the outside. This is going to be A and B. So how many people would satisfy both A and B? How many people are high school grads and homeowners?
221.
221, thank you. So 221, absolutely. Now, this portion is going to be A but not B. So we have a total of A's high school grads. We have a total of 310 high school grads. 221 of them were homeowners, so 89 were not. So this is going to be high school grads who are not homeowners. That's going to be 89. And the whole circle of A will add 310. Then for B, these are the people who are homeowners, but don't have a high school degree. We have a total of 340 homeowners, 220 of which are high school grads, 119 are not high school. So that's what it's called two-way till you read it another way. So that would be 119. And of course, those who are neither would be 71. And altogether, all should add to 500. All four numbers should add to 500. So we're going to now deal with probability using this data here. So here's what we'll do. I'll put you guys in a breakout room really quickly. Should take just maybe about 3 minutes, and then we'll come back to this. Or actually, won't do a breakout room. I'll just give you guys 2 minutes to think about it. So going to do part B, parts 1, 2, 3, and 4. High school grads who own a home, what's the probability of that? What's the probability of getting a high school graduate who doesn't own a home, or not high school grad but owns a home, or not high school grad who doesn't own a home? So essentially, you find the probability of A and B. Here, you find the probability of A and no B. Here, you find the probability of no A but B will exist. Here, you find the probability of no A and no B. So take a second to think about that. Okay. So if we get in this, the probability of A and B is going to be 221, because that's 220 people do both out of 500. And you can leave your answer like that. That's totally fine. If you want to give us a decimal, it's 0.442. Usually 3 decimal places is generally a good idea. What's the probability A and not B? So that would be 81 people. 89 people, sorry. 89 out of 500, which is 0.178. What's probably not A and B? That'd be over here. 119 out of 500 people, which is 0.238.
But Mr. Mashni,
Yeah, go ahead.
I don't really understand why is it like instead of 310 for like number.
We're trying to find the probability of all people in this survey, I guess, or this community. Because if you're say given, that's called conditional probability. That's what you're thinking of, Teddy. If I said given you're a high school grad, what's probably you own a home, then that'd be 220 out of 310. If I had used the word given that you're a high school grad. I'm just asking you, A, what's the probability of these 500 people that you're a high school grad and you own a house? I think I'd be a little more clear with my wording. I'd say
Yeah.
Of all the people, and I'd probably start by saying you surveyed 500 people. Of all the people you surveyed, so I think I'd be a little more clear. The wording's not the best here, but does that make sense?
Yeah.
Okay, cool. Okay, and then probably no A and no B. That'd be 71 people out of 500, which is 0.142. Okay. Hopefully we're okay there with that. Let's try another example before I have you guys do some practice on your own. Okay. According to the National Center for Health Statistics in December 2008, 78% of U.S. households had a traditional landline telephones, 8% had cell phones, 6% had both. Suppose we randomly selected a household in December. In 2008, okay. So first of all, let's do a two-way table. So this will be a landline. This will be cell phone. And sorry, I take it back. Landline and no landline. This will have a cell or no cell phone. Now, you told us 70% had a landline. So that'd be 0.78 right here. Therefore, this would be 0.22 because everything should add up to 1.00 if you're dealing with percentages. 80% had cell phones, so this would be 0.8. This would be 0.20. That should add up to 1.00. Now, 6% had both, so that'd be 0.6 right here. Therefore, this would be 0.2. That's 0.2, that's 0.02 right here. If that's 0.6, that's 0.18. So you always kind of start with the middle part and then kind of figure out what the rest would be. So that's how you would fill it out. And then you can also do a Venn diagram if you so desire. 0.6 do both. Let's say A is landline and B is cell phone. So to have a landline but no cell phone, that'd be 0.2. Sorry, landline but no cell phone is 0.18, my bad. Because it's 0.78 total for a landline. So you have a cell phone but not a landline. So cell phone but no landline, that's 0.2. And of course, it's 0.02 to have neither. And all should have to 1.00. So for C, find probability the household has at least one type. So at least one type, that means they have both, or just one. So that's going to be the probability of A or B, which is going to be all this right here. So that's going to be 0.98. Because you could have just a landline or just a cell phone, or you could have cell phone and landline. You're looking at all three of those scenarios if they have the word at least. The word at least, it's very subtle, but it's very important. Find the probability that the household has a cell phone only. So probably B, but no A. Well, that's cell phone, but no landline. That's going to be 0.2. So using a two-way table or a Venn diagram, either way would be fine. So what you guys are going to do next, you and two others in a breakout, we'll do 3 breakout rooms with 3 people. This one's talking about a standard deck of playing cards. And if you don't know playing cards, it's okay. There are 4 suits: clubs, diamonds, hearts, and spades. Each has 13 cards with denominations of ace, 2, 3, 4, 5, 6, 7, 9, 10, and then jack, queen, king. So let's say event A is getting a face card, which is Jack, Queen, or King. Event B is getting a heart. There's going to be some overlap, of course, because there is a Jack of Hearts, a Queen of Hearts, and a King of Hearts. So you make a two-way table, which will look kind of like this. So this is hearts, no hearts. And then, of course, you have face or no face. So we'll be putting exact numbers in there. You know, how many face cards have hearts? How many face cards don't have hearts? How many of the hearts don't have faces on them? How many of the how many cards don't have hearts and don't have a face on them? Then you're going to answer C and D, and of course make a Venn diagram too, and fill out the two-way table. Then after that, you guys will work on number 4. Number 4 is asking why a Venn diagram would not be appropriate. You'll answer that question. And then part B, you're going to kind of answer that question. Part C, and then they'll do number 5 after that. So I'll give you guys about maybe 20 minutes to go through these problems. We'll come back, and then we'll start talking about some of the items I'll have in the test review folder for you guys. So again, you guys do number 3. I kind of give you the two-way table to get started. You'll fill out the Venn diagram. You could probably let this be hearts and this be face, if you guys like. Yeah. So let me stop sharing, put you guys in your breakout rooms, and there's a question in the chat. Okay, thank you, John. John's back.